Archimedes Principle is the make or break topic of Unit 9. It's one thing to say object floats, but it's another to calculate the exact Newton value of that upward force. Today we are mastering the displaced volume logic. I'm going to show you why you don't actually need to memorize 10 different buoyancy formulas if you just understood how to draw a proper free body diagram. This is the foundation for the hardest FRQ in the unit. If you are feeling overwhelmed by the maths, remember I offer one on one private classes to help you crush these problems step by step. Email me at yourphysicsbuddy@gmail.com. Now let's figure out why things float.
So in the last class, we talked about pressure exerted by a liquid column and we came upon a formula which is rho gh, where rho is supposed to be the density, v is supposed to be acceleration to gravity, and h is supposed to be the depth of the liquid column. We
Yes.
described few principles like hydrostatic paradox. We talked about how pressure will change if the container is open or closed. So based upon those things, we understood how to calculate pressure. Then we did some numericals based upon that only. Then we came across a very important phenomena which is known as buoyancy. So buoyancy is basically the upthrust which liquid exerts on any object when they are poured into it. So it is a tendency of every type of liquid. Like if there is a liquid, it has that tendency to apply buoyancy. Specifically, not liquid, I should say fluids, because gas do does the same just as the liquid do.
Yes, sir.
Apart from this, we talked about Archimedes principle. We understood how much force is actually an object is going to experience based upon the density of it as well as the density of the liquid. So we just came across a relation which is V rho G, where V is supposed to be the volume of liquid displaced, rho is supposed to be the density of liquid, and G is supposed to be the acceleration to gravity. So based upon this thing that how much an object is immersed inside a liquid, we apply that relation. Last but not the least, we talked about law of flotation, which actually help us to understand that in which case object is going to sink and in which case object is going to float in water or liquid. So I gave you one question here as homework. Did you track that question?
Uh, Sorry, sir. No, I did not.
But make sure you do it.
Okay,
All
sir.
right, let's do it right now. Try this out and tell me how we are supposed to answer that question.
Okay, sir. 1 second. Solid weight 6 kilos in air. If its density is 2000 kilometer cubed, what will be its apparent weight in water? Okay, so apparent weight in water. Oh, so it will be the weight of the thing minus the force of the buoyancy that the water
Correct.
exerts. So force of buoyancy is equal to rho gh, right?
Yeah, so you can call rho GH,
Rho
not rho V
oh
rho G.
rho v
Yeah,
rho vh, right? Rho vh,
rho VG, rho VG.
rho vg. Oh yeah, okay, rho vg. Uh, Wait, can I see the question, sir? The rho vg. So its density is 6
Density
kilos.
2000 and the mass in air is given as 6 kg. So what we have given is the mass of the object which is 6 kg in air. Then we have the
Okay, so we
density
can find
of object.
mg, which is um 60 newtons, and then since the density is equal to 2000,
Okay, go ahead.
Wait, I need to find the volume it displaces. Density is more, yeah, density is mass over volume, right?
Yeah.
So if density is mass over volume, I can say 2000 is equal to the mass, which is 6, over the volume of the thing. So the volume now will be 6 over 2000. Yeah, 6 over 2000 is equal to the total volume of the object. And if
Then
the
you are supposed
thing,
to find out the mass of water displaced. Like how
yes,
much
so the
water
water
once you get.
displaced, yeah, so it will be the apparent weight will be Fg minus Fb, which is equal to 60 minus the density 2000 times g times v. So I need to find the buoyancy.
See, you can do that way as well, but it is easier to do it this way, where you are simply trying to find out that how much volume of water is displaced. Once you find out the volume of water displaced, you can easily calculate the mass of water displaced.
Wait,
So
how did you find out that the volume of water displaced, the mass of water displaced? Did they give that to you?
based upon this information that the mass of the object is 6 kg and the density of object is 2000 kilogram per meter cube, we can find out that how much water it is going to displace if it is kept in liquid or in water. So volume is nothing but mass upon density. So we can write it as 6 over 2000. So this is the volume of liquid or water that is going to displaced. Now we have to find out how much mass is going to get displaced. So once we do that, once we try to find out mass is nothing but volume times density. We already find out volume, which is 6 over 2000 times, and density of water is 1000. So this will give us that 3 kgs of water will get displaced. So the
Oh yes,
apparent
it's a
weight,
thousand times. Oh, the water's density is 1,000, right? Oh,
yeah, so the apparent weight of or apparent weight in water of the object is going to be 6 minus 3, that is 3 kgs, because that
wait,
object
wait,
is capable
sir,
of
I'm
displacing half
confused
of the
about one
object
thing.
only.
I'm
Yeah,
confused about one thing. Why did you multiply it by 1,000? Was it because of like specific density or something like that? Like the I don't
density is
understand that part.
mass over volume. So mass is density times volume. Density of water is 1000 and volume which we calculated is 6 over 2000. So this is how we got 3 kgs as mass of the water displaced. And the mass of the object is 6 kgs. So the apparent weight is going to be 6 minus 3, that is 3 kgs. All you need to do is
Density.
you need to find out that how much water has been displaced by the object. If you get the mass, then you can simply do it like that. Let's do more problem on this.
Okay. Oh, so in this case, the mass of the object was 6. So in order for the ratio to equate. Okay, okay, that makes sense, sir. Okay.
Let's try out this one. So the question says a solid float in water with 3 by 4th of its volume below the surface of water. So 3 by 5th of volume is below the surface of water. We have to find out the density of the solid. Calculate density of solid.
Okay, if 3 by 4 of its volume is below the surface, then wouldn't that just be 3 over 4 times 1,000 or something?
Yeah, correct. Now you got it. But let us see
Oh,
a proper way of doing it. Because if such question came in FRQ, then you're supposed to solve it properly, not You just answer this way. So how we are supposed to answer such questions? Let us try to understand. So let us first of all assume that the density and volume of solid is rho and v. That is what we have to assume. This is density of solid and this is its volume.
Okay.
So here, if you try to find out the weight of the solid, what its weight going to be?
And maybe mg.
mg.
Oh,
And
like, yeah.
mg can be written as rho vg, right?
Oh, really?
Yeah, mass is density times volume.
Oh, yes, yes, yes. Oh,
So
okay.
what is given to us is that volume of block in water. This is what which is given. Volume of block in water is 3 by 4 times of its volume, which we assumed V, right? Now, this much volume of block in water is equals to volume of water displaced, right? Like this much water in terms of volume must be displaced in order to have that block inside water. Are you getting it?
Because 3 by 4, like, of the volume occupies the water.
Yeah, it's inside. 3 by 4 the volume is inside. So how
So
much
that's
water is going to get displaced?
3 by
Whatever
4.
volume of object is inside. Yeah, 3 by 4. So here simply we can say that weight of water displaced is equals to 3 by 4 times V into 10 to the power 3, that is the density,
So
into
I have a question.
G.
In a fluid,
Yeah,
if I put, like, let's say, um 2000 cubic meters worth of volume inside it. So would that mean it always displaces to the water always gets the liquid always gets displaced by 2000 cubic
yeah, the
meters?
volume of liquid displaced is going to be 2000 meter cube.
So no matter, like, even if it's not water, would that still be the case?
Yeah, if it is not even water, if it is any kind of liquid, then the volume of liquid displaced is always the volume inside the liquid. Volume of the object inside the liquid. Whatever volume it is inside, it doesn't matter. Whatever liquid it is, it doesn't matter. But yeah, the buoyancy is, or the buoyant force is due to the volume of water displaced or the liquid displaced. So once we solve this relation, like weight of water displaced is going to be 3 by 4 of 10 to the power 3 times g. Now, what is weight of body? It is that. So you can simply equate these two equations. So it will be exerting mg downward, experiencing v rho g upward. V rho g, rho is the density of object, density of liquid. So here, weight of body must be equals to volume, weight of volume displaced. I'm talking about liquid. So mg must be equals to 3 by 4 v 10 to the power 3 times g. Mass can be written as density times
Volume.
volume into g. 3 by 4v 10 to the power 3g. Now this is what we have to find, density of the object. V will cancel out V, G will cancel out G. So density is going to be 3 by 4th of 10 to the power 3. So density of object is going to be 750 kilogram per meter cube. This is what we are supposed to find, density of object. Now this is the actual way of doing it. All you need to understand is that how and why we did this. We always have to consider that there must be some fraction of object which is inside water, and because of that fraction, because of that volume only, the object is going to experience binding force, not because of the whole object. Whereas the force which is acting downward will always be mg. So these are the things that you need to keep in your mind. Is it clear?
Yes, I'm just when you say you displace 3 by 4 amount of water, right?
Hmm.
But wouldn't you displace less than that because of the force of buoyancy?
It's not like that. Buoyancy represents that 3 by 4 of volume is displaced.
Oh, so it's a
Buoyancy is
counted for.
acting, yeah, buoyancy is acting because of that displaced 3 by 4 volume. If the volume 3 by 4 is not displaced, then there is no buoyancy. Or sometimes the object's structure is in that way that they don't experience that much. MG is not capable enough of letting that object sink. So every time we are solving such questions, we just have to understand that how much fraction of volume is inside. So whatever amount of volume is inside, only that volume will going to apply bind force in the upper direction, whereas mg will be due to the whole object. That is what we need to understand.
Okay. Because I was just a bit confused by the previous thing. If you can go back to the previous slide, sir. Uh,
Mm.
like I kind of understood it, but I did not like really get it. I did not like understand. Like, okay, our volume is 6/2000, right?
Mm.
But how, that does that mean we like display 6/2000 water?
No, understand. Try to understand it this way. So suppose we are supposed to find out bind force here. All right. So
Yes.
there is an object. This object is of 6 kg mass. Density is 2000. Mg will be acting downward, which is going to be what?
Uh,
6
60.
times 10. Now let us talk about bind force Fp. Fp is what? V rho g.
Yes, sir.
Now rho is supposed to be the density of object. The only thing we don't know is
The displaced
volume.
volume.
Or we can also write mg, but here this mg is mass of water displaced. So how are we supposed to find out mass of water displaced? Like that. So Fp which is acting upward must be 30 Newton, whereas mg must be acting downward is 60 Newton. So the net force is no doubt in the downward direction, which is 30 newtons. So the apparent weight, what is apparent weight? Apparent weight is something, the net force in the downward direction. So net force in downward direction is 30 newtons. So mass must be 30 by 10. That is 10 kg. Now you got it?
Yes, sir. Okay.
Let's do
Okay.
more questions.
Because sorry, sir. When I said density is equal to mass over volume and you did 1,000 times 6/2000, I thought the volume in this case was referring to like the volume of the water. That's
No,
why I
no.
was confused.
Yeah, this volume is volume of water. Or you can say this mass is the mass of water displaced. So
Okay.
again, there are two things. First of all, you are assuming that object is floating. First of all, in this case, object will not float because the density of object is much more than the density of water. So it will definitely sink. The second thing that you should not think here is that the buoyant force in such cases where the density is much more than the density of the water, buoyant force has a constant value that will continuously act. And for that, we try to calculate buoyant force based upon the complete volume inside, a complete volume uh, inside the liquid. But the thing is, the mass is going to move in the downward direction because of the weight, because weight is more than the buoyant force. So it will continuously move. It will have an acceleration downward, and there are different things simultaneously we'll observe here. So it is a different scenario, whereas the question we did next is a little different because here there is no information about how much object is inside water or outside. But here it is clearly mentioned. So We are just combining these two problems. Let's do more. Let's do more.
Okay, sir.
So the question is a metal cube of 5 centimeters side and relative density 9 is suspended by the thread so as to completely immersed in a liquid of density 1.2 times 10 to the power 3 kilogram per meter cube. Question is find tension in the thread. Now try this out. First of all, whenever we are supposed to do such questions, try to draw them. Try to draw a clear picture of this question representing all the forces. Like whatever number of forces acting in whatever direction, we just need to draw that.
Okay, sir. So metal cube of 5 centimeters side. Okay. Is 9 and RD. So what is RD?
Relative density.
And okay, RD is 9. What is the relative density, sir?
This shows that we are not revising.
Is it the ratio
Yeah, it is the ratio.
like of water and the other substance?
Yes, it is the ratio of density of substance to the
Okay.
density of water at 4 degrees Celsius.
Okay, okay. Oh, so it's the same thing as specific gravity. Suspended by a thread. Okay. And then so that is completely immersed in a liquid. No density. So density is find the tension in the thread. Oh, okay. So the tension will be the apparent weight. Like basically it will be Fg minus Fb.
Correct. Now solve it and tell me the answer.
Okay. Yeah, sorry. It will be the weight of the object in the water multiplied by g. And then yeah, because it has to exert a different force. So it will be like Fg, Fb, and then the tension pulls up. So T plus Fb is equal to Fg. So then T is equal to Fg minus Fb. Okay. So Fg is what? Oh, density is equal to mass over volume, right? So then mass is equal to density times volume.
So this is how you're supposed to solve this question. Here, this is sigma, and I
Okay,
assume sigma to
okay.
be density of object, which is given as
It's the mass over the volume, but they did not give the mass, sir. Oh, but they gave
but
the relative one. They gave relative. Oh, okay, okay.
they didn't give the mass, but they did give us density as well as volume. So we can find out mass by calculating density times volume.
Oh, okay, okay, sir. So then so if I have x over the other object's density, which is 1.2 times 10 to the 3, I can set that equal to the. Oh yeah, I can set that equal to RD, which is 9, right? So x is equal to 1.2 times 10 to the 3 times 9. That's the density. Yeah. How do you know if the density of the substance it gives goes on the top or the bottom of the ratio?
Like what?
How do you know, like, okay, on the fraction, right, that the liquid that of the density they gave, right, goes on the top or bottom, the numerator or
First of
denominator?
all, first of all, you need to understand that that how the object is going to behave, whether it is going to sink or whether it is going to float. Based upon that, you can simply apply it. In maximum cases, again, the thing which you are calculating depends upon that, like what you are calculating. That which comes in the numerator, which comes in the denominator, completely depends upon what you are calculating. You learn. You did see this thing is something which you can only learn if you practice. Without practice, cracking these kind of questions is not easy. So I will suggest you to do some problems. Whatever assignments you're getting from school, make sure you solve each and every assignment. And if there is any doubts, then ask.
Okay,
Yeah,
sir.
this is the question. I'm not able to get it, but try such questions first of all. You need to try as many as possible. First of all, you need to imagine the situation, like what exactly is happening. If you're able to imagine all those things, if you're able to visualize that how actually the diagram is being given, then you can easily solve it.
Okay, so I was a bit confused because they said that like this formula for specific gravity, right, is the density of substance over density of water. But in this case, it was not water; it was a different substance,
Yeah.
right?
No, no, no,
It was
no, no.
another
Yeah.
liquid.
Okay, okay. Wait. You didn't understand it well. Then try to recollect this thing. Relative density is density of substance
Okay, I'm going to
into
review the
uh,
notes.
yeah, density of substance over density of water at 4 degrees Celsius. So
Yes.
density of substance is what? RD times density of water. Now here density of substance, we should be writing density of liquid because we are supposed to find out the density of liquid here, which is already given. We have to find out substance. So it is going to be 1000 times 9. That's it.
But sir, in the problem, they did not say that it was water. They said liquid.
No, 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 no. Relative density is the term which is defined by referring water only. We are not defining relative density with respect to any other liquid. Whenever it is given that relative density is that, it means that number times 10 to the power 3. That is the density of substance. Because
Okay, so in the problem by liquid, you meant water, like the water density. See, yeah, okay,
no, no,
okay.
no, no, no. Again, you are mistaking. Okay, try to understand it. Relative density is the term which we use as a reference. Like, for example, suppose there is an object,
Yes, sir.
its density is 2420 kilogram meter per cube. Then there is another object which density is 7990 kilogram per meter cube. Another object having density 840 kilogram per meter cube. Now, in order to represent these big numbers, we just opted out something else. We made ourselves remember the relative density instead of remembering their densities. What is the relative density? Relative density is just a ratio of substance density over water density. So here we got a number that is relative density. Similarly, for second it is going to be 7.99. For third it is going to be 0.84. So relative density is just a number which actually help us to write density in short numbers, or you can say in whole numbers. You don't need to represent big numbers here. So it's just an idea. So in the question it says that relative density of substance or our object is 9. That RD of object is 9. It is given. So what does it mean? It means that the density of object is 9,000 kilogram per meter cube. Instead of writing 9,000, we just write RD of object is 9. So it means that 1,000 times 9 is the density of object as per the definition. So relative density is just a number. It doesn't refer to this thing that in which type of liquid our object is placed. It is just
Okay, okay. It's just a
the
ratio.
representation. Yeah, it is just a representation of a density of an object with reference to density of water.
Okay, okay, okay.
It is simply like suppose you have taken a reference and you are using that reference in measuring everything's density. That is relative density. And that reference is nothing but water.
Oh, so if
So
you go back to the previous problem, the RD that they gave was the ratio of the cube's density to
to
the
the density of water.
to water at 4 degrees Celsius.
Yeah,
Oh,
that's
okay,
it. It's
okay.
not a number or something. It just helps us to understand density of liquid with reference to the water. That's it.
Oh, so we can say 9 is equal to the density um of the cube over over 1000, right?
Yeah, 9 is right.
So 9 times 1. Okay, okay. So then I did it incorrectly. Okay, I wrote it incorrectly. Okay. Okay. So in this case 9 is equal to, so density of the cube divided by 1000, right?
Hmm. Right.
Okay, which is equal to 9000. It's a very dense cube. Okay, that makes sense, sir. Because I was doing density of I was doing how do I put it? I was doing 9 times 1.2 times 10 to the 3. That's why. Okay.
So this is what you will get after solving this equation. That is 9.55 newtons.
Okay, sir. It's equal to 9.55. Okay. Can you hear me, sir?
Yeah.
Okay.
For this, so you have
Yes,
test
sir.
tomorrow, right?
No, 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 not tomorrow.
On Wednesday.
No, no, no. April.
All right.
I have
All
more
right
time
then.
to
Yeah.
procrastinate.
But make sure you utilize this time well and do as many problems as possible.
Yes, sir.
So let's move to the next topic and let's talk about viscosity. So viscosity is a property of a liquid. It is a property of fluid, which actually help us to understand that how much backward force a liquid can exert if something is passing through the liquid. So you can simply say that it is the property of fluid by virtue of which an internal force of friction comes into play when a fluid is in motion, which opposes the relative motion between its different layers. So we can also understand this thing as fluid friction. So viscosity can also be regarded as fluid friction. Just assume that you are standing near a traffic signal and suddenly there is a huge blow of wind come to you. Now what you try to do is you try to move yourself against the force of wind, and wind is quite heavy, you can say. So what you will feel? You'll simply feel a resistance offered by the fluid, that is air. And fluid in motion does it more rapidly than the fluid which is still. Let us try to understand this concept through a different example, a different perception. So you must have seen different videos of different people going out in sea and doing scuba diving and all. You must have seen, right?
Yes, sir.
So if you just forget about the top layer of liquid or the ocean, let's go deep into it. So when once we go deep into oceans, near the rocks where there are few plants as well. So what you generally observe? You observe that the bottom or the ocean's bed is not in motion. What you will observe that the bed or the bottommost layer of ocean is at rest, complete rest. Why we can say that bottommost layer is completely at rest? Because the sea bed is at rest. So what happens here is at the surface there is a breeze, and that breeze just pulls off the water. But at the bottom there is nothing. So what we observe here is due to breeze, the top layer has huge velocity. We can assume that it has some great velocity. But as we move down, the velocity of passing layer decreases, and at the bottom it becomes zero. This is something which is also known as velocity profile, which shows that layer by layer, as we go down deep into the ocean, the layer's velocity keeps on decreasing. And that decrease in velocity simply represents, or it is simply due to viscosity, that is the
Friction.
physical property.
Oh, okay. Okay.
Because every layer inside a liquid tries to oppose the motion of the upward layer or the layer in contact. Or this is how nature works. This is how we generally observe ocean currents and all. Majorly, waves are created due to those high breezes, high speed breezes that flows over the ocean. and we do observe a lot of sea breeze over the ocean. And that is how everything runs, everything works. So what you have to understand or what you have to keep in mind here is that the topmost layer of the ocean has the highest velocity, whereas the bottommost layer has zero velocity. And that is the reason why it is quite easy to go deep into ocean than to keep yourself at the top layers. That's why surfing is one of the most difficult thing to do. It requires a lot of, you can say, effort as well as wisdom. You need wisdom to do that. So here again, viscosity will give us a force that is called viscous force, and we will try to understand that what is the relation for viscous force and on what factor the force of viscosity depends. It will be again important and it will be used in different numericals as well. So on analyzing the situation, we find out that force of viscosity, which is also called viscous force, it can be represented by Fp. It is directly proportional to the area of layer. Viscous force is directly proportional to the area of layer as well as it is directly proportional to the velocity gradient. Now this is an important term. Let's talk about velocity gradient. So wherever you see gradient term in physics, it simply represents that how this quantity is changing. So basically change in velocity with respect to position. That is what gradient means is. So basically change in physical quantity with respect to position is called gradient. Now let us understand how we can apply it here. Suppose there were two layers and these two layers were separated by a certain distance. You can call that distance as dx. And what I can call is if the velocity of this layer is v, so velocity of the layer above it must be v plus dv, as it is must be more than that. Whereas the layer below it, it must be less than
Sir,
the
sir,
velocity of
sorry,
the layer.
sorry. Our teacher told us that like viscosity will not be tested.
In your curriculum.
No, there's no viscosity or any like integration or anything like that. Like we assume the fluid is completely ideal.
Yeah, we are not going to do that.
Yeah, yeah, but there's no like questions about viscosity.
Okay, it's fine.
Okay.
It will help. Don't worry. There will be some questions, some theory-based questions, or you can say some conceptual questions, which might ask you this. See, because the gradient term is not something which is limited to this particular unit only. It can be, has a lot of things in different parts of physics as well. So just try to have an idea what is this gradient term is.
Oh, it's the change in velocity.
Yeah, so that change in velocity with respect to displacement, that is dv by dx, is called velocity gradient. So once we combine these two equations, we simply have that viscous force is nothing but eta a dv by dx. Now this dv by dx is not something we are going to differentiate or integrate. This thing has a value. This thing will have a definite value and you can use that value directly
Is
or
dv the change in volume or change in velocity? Change in velocity.
change in velocity.
Change in velocity. Okay. Oh, so this is like scientifically determined or something like experimentally determined.
Yeah, because in physics, we cannot have answers to all the questions, but experimentally we can find this thing out that on what factors this particular thing depends. But why it depends on that thing only, it is sometimes quite difficult to answer. So that is the only thing that you need to keep in mind regarding
Okay.
viscous
So
force.
the velocity depends on the depth. Okay.
Not, yeah, you can say that. With depth, it will change
I'm a bit confused, like, but why does the velocity decrease with depth? Like, why should it decrease?
because at the bottom, the particles are at rest. So the layer,
Does it have to be at rest, sir?
in order to move that layer, the topmost layer must be very highly moving. It should be moving very with what lot of speed.
Oh, okay, okay.
What we understood, like in kinematics, what we understood. If something is moving, or when we are talking about friction, what we understood. Friction is a kind of force which either wants you to walk along it or either to stay on it. Like, let us understand an application of friction. It will ultimately connect you with this. So, when we kept our backs on this conveyor belt, what happens to the object? Because of the friction, the back moves. If there is no friction, what would happen? The back stays there only.
It's
So,
slipping.
whenever, yeah, because it's not slipping. If the friction is not there, then it would be slipping, and because of slipping, it should not be moving. Like Hawaii, it is difficult to walk on ice because coefficient of friction is very less. There is no friction to support motion. Similarly, here as well, if it is at rest, what it want, all the surrounding particles around it, it want it them to be at rest as well because they are connected. Similarly, as we move up, the topmost layer is in motion. So the topmost particles must be in motion because of the topmost layer is in motion. But as we come down to the bottom, the particles ultimately comes to rest because the bottommost particles of the ocean bed are at rest. So that
So
is
if
something.
we're swimming very deep in the ocean, is it going to be harder than swimming like in a shallow part?
It depends upon how deep you are moving.
Like if we
Because
compare our swimming like intensity at the ocean floor compared to swimming at the ocean surface.
okay, every place has different challenges because in the depth the pressure increase. It makes swimming difficult because of that. But also at the depth, if you are wearing a proper swimsuit which controls the pressure and everything, then it will be much easier. That's why the scuba divers or the scuba diving becomes an adventurous activity only because there you got the complete all form of equipment that is needed and it makes it very
Dangerous
easy. And
activity.
also the water, yeah, and also the quite water is also quite, so there is no such thing that you might flow with the water and all because you are at the bottom, you are near the reef, coral reef, so it will make it easier for you to swim
So if
there.
I went deep enough, because the pressure around me is much higher than the pressure in my body, would that mean like since my body is at a lower pressure and my surrounding environment, which is very deep, is at a high pressure, would that mean that a lot of the fluid would enter my body?
No, you are not going to experience any osmosis there so that your water enters into your body, but the blood flow will get hampered because the pressure inside your veins, the blood pressure inside your veins is lower than that of pressure outside the body because you're deep inside it. So that blood pressure, there is a situation, there is a possibility that at very deep into the ocean, your vein might collapse, but that is only happen if you go way too deep. And
I thought
most of the
I thought high pressure must go to a low pressure environment. So like why wouldn't the water like enter our nostrils or anything like that?
first of all, for liquid to go from high concentration region to low concentration region. High concentration means salts. Low concentration means lesser salt. So inside our body, if you're talking about human body, it has less number of salts in it in comparison to the ocean, which is outside.
Okay.
And once you go into the ocean, all the openings of our body, they just creates we can say suction outwards. Like all the air inside our body will be in a body until we expel it out. Until
Really?
we, yeah, it cannot come outside if we didn't expel it out. Now, what happens is when we are deep into the ocean or when we are into the water, sometimes somebody suffocates. That suffocation allows water to enter. If you don't suffocate, you can stand still. Water won't enter into your body unless you allow or you start behaving that way. That it gets that chance. Again, you need to be very calm and composed while inside water.
Okay,
So
okay.
there are a lot of things. All